Hi, in this video we're going to look at using RStudio to check an assumption which is quite common in a lot of statistical tests, which is homogeneity or equality of variances. So we can imagine a situation where we're trying to compare two groups, Group A and Group B, and we'll make some assumptions that we're going to use a t-test. And a t-test is used to compare the means of two groups. At least in this circumstance, a t-test will be used to compare Group A and Group B. The effect size that we will often use is Cohen's d. And Cohen's d is an effect size that describes mean difference in standard deviations. There's a lot of variations of this, but if we wanted to do that, if we wanted to say how many standard deviations one group may or may not be different to another, then it's important to understand if those two groups have either the same or different standard deviations. That will affect our calculation of effect size and our interpretation of effect size. So that's just one of the situations where we would want to know or check the assumption of homogeneity of variances. And there are a couple of ways to do this. The most common is the statistical test, the Levene's test. But we can also look at this by comparing, for example, just the standard deviations between groups, and we can get a visual inspection, for example, by creating a density curve. So we'll take a look at all of those three options, although the most robust approach to doing so would be the statistical Levene's test. The others can kind of give an indication. So we'll start off and we're going to test for equality variances. Now, we can do this first of all or get an indication by looking at standard deviation. And we've already, in prior videos, looked at computing standard deviations. We did it earlier when we were looking at descriptive statistics. And one of the ways in which we were able to identify standard deviations was using the psych package and the describe by function within that. And we labeled that iris descriptives. This is the iris dataset. So I will just run that code again and pull up that descriptive statistics table. And here it is. So we can see we have these three groups, the three different species, Setosa, versicolor, and virginica. And it will just take one variable. Suppose we wanted to check the variances and to test if there are equality of variances between the three species on the sepal length variable. So our first standard deviation for the Setosa is 0.35 standard deviations, and that's a measure of variation, standard deviation in that variable. Then we have a 0.52 and a 0.64. So we can see that they are different in absolute terms. We also may want to visualize that, and we can visualize that by looking at a density curve. And we did that as well earlier by looking at a density plot, which we called iris density. So if I run that, you will see the three density curves, and what you're looking for is the spread of the data. You could also see this in many other ways, but this plot gives an indication. And what you can see is Setosa is much more condensed. There's less spread around what could be a mean value or a median value in comparison to versicolor and virginica, and you were able to see that from the standard deviation being smaller for the Setosa variable. Getting that kind of indication, it suggests that there may be what's called heterogeneity of variances, or a difference in variances in the sepal length variable between these three different groups, the species. And to check that statistically, we would use a Levene's test. So the Levene test is a function in the car package. So I'm just going to go back up to the top of my script, load the car package, so that I can use that particular function. So the package is now loaded, and we're going to use Levene test. So it's, and the one that we want is in this car package. You can see it's also in the or statics package as well. But we're going to use this Levene's test here. And you can see when you hover over it, it computes Levene's test for homogeneity of variances across groups. And it has a formula to do so. So I'll just go into the package just to demonstrate this. So it's Levene test, and here it is. And you can see some examples of it here. So Levene's test, and there's a variable, and the tilde symbol, and then there's something more. In this case, it's showing one variable multiplied by another. The kind of generic formula for it is to include the arguments of y, where y is a response variable, group, so a grouping factor, what are the groups that we want to compare, center, so you can see here the default is to center around the mean, but we can also center around the median, and the median is a more robust measure. So the mean gives the original, the default, median. Okay, so the default is median, my apologies, and a data frame. It is data. So we'll use this. So I suppose we can attach our iris data first. We could specify data if we wanted to, but this, I guess, is just a force of habit for me. So we'll attach the, I called it Irish by mistake. So we'll attach the iris data set and do a Levene's test. So what we want is to compare groups on our response variable. Our response variable is sepal length. And the way we can write this is we can use the tilde argument and species. So what we're doing is it's Levene's test to compare the variances, or to determine if there is differences in variances on our sepal length variable between the different species. And just to be absolutely clear on it, we will center it around the median, even though this is the default. So there's our code. Unmatched. And here we go. So our p-value, we can report this as Levene's test. We have an f value, so it would be f, and our degrees of freedom are 2 and 147, equals 6.3527, and p equals 0.002259. In other words, p is less than 0.05, and therefore we conclude that it's statistically significant. We reject the null hypothesis, and therefore we conclude that our variances are significantly different, statistically significantly different. In other words, we don't have equality of variances. However, it's important to note that this included 3 different species, and perhaps we might only want to compare 2 different species. Well, earlier on in a previous video we looked at creating a data set which only included here, so which only included one of the species. And the Levene's test formula takes the entire data set and looks at the grouping variable, and the grouping variable here had three levels, or three groups to it: Setosa, versicolor, and virginica. So we may want to create a data set which only includes two of these. Perhaps we only wanted to compare Setosa and versicolor, because they might be the two groups that we're interested in at virginica. So we have to manipulate our data and create that data set first. So I'm going to call it the first one Setosa for virginica data, and I'm going to create that using a similar approach to before. So it'll be the iris data set. I think I can actually get rid of the which option here, and that would get rid of these. So it's going to be the iris data set, and I'm going to take the species variable, and rather than equals and equals, which means is equal, I'm going to put in an exclamation mark. So is not equal to, and then the one that it's not going to include. So for example, we're using Setosa and virginica, which means the one that we're not going to have is versicolor. And I'll just make sure that I am spelling this correctly by taking a look at the iris dataset. So it's Versicholor, Versicholor. So I'm going to have a data set now which has Setosa and virginica, and it's created by taking the iris data set and then creating a data frame which is based around the iris dataset species variable not being equal to versicolor. And when I run this, what I end up with is Setosa virginica data now saved into my environment, and it has Setosa and virginica but not versicolor, which means if I wanted to now, I could do the same code as before, except rather than attaching the iris data first, I would attach this data set, so the Setosa and virginica data only, run my Levene's test. I can use the exact same code because it's still the sepal length variable and it's still species, but now species only has those two different groups, and we'll center it around the median. And here we can see, again, we end up with a statistically significant difference, which is that the two groups now, the groups of Setosa and virginica, are significantly different in variances. I can compare all of them. So for example, I'll just copy and paste that code, and rather than Setosa and virginica, I could have Setosa and versicolor, and I would want that data set to be made without virginica as a species being included. And I might want a virginica versicolor data set, which would be one created without the Setosa. Species. If I run that, and we'll see them appear in my environment, and you can see they've got 100 observations of 5 variables each, same as before, and I can now repeat this code multiple times, except using the different data sets. So I'll simply attach the different data set that I want to use prior to using the function and computing the response to the Levene's test. Here we can see that Setosa, so I've attached the Setosa versicolor data first, and after that I've run the Levene's test. So Setosa and versicolor, the p-value is also below 0.05, so they are statistically significantly different, and they have different variances. And in the last one, Virginica and Versicolor, if I run that, here now we see that the Levene's test comes back and it's not statistically significant. In other words, the variances are not significantly different. And that has implications for particularly effect sizes that we compute. In this case, we might want to opt for perhaps the Hedges G effect size as opposed to Cohen's D. And if we revert back to what we looked at previously, so the only one so what it appears to be is Setosa is significantly different from the other two, but they're not significantly different from each other. I'll clear this for a moment. If we look back at our descriptive statistics, I'll make this a bit wider first. We can see Setosa had a standard deviation of 0.35 versus 0.52 and 6.4, so these were closer together. And if we look at our density curves, we can also see that the Setosa one is much narrower, whereas the curves look to have a similar spread for Versicolor and Virginica. So that's where we can get an indication from standard deviations and the likes of a density plot. But the Levene's test is the statistical approach to checking that particular assumption and seeing whether we do or do not have homogeneity or equality in variances between groups.